Hello, and welcome to our AP Chemistry review of topic 7.5, magnitude of the equilibrium constant. So the equilibrium constant is a ratio between the concentrations of the products divided by the concentration of the reactants. And so I've given you a generic reaction here where substance A is reacting with substance B to produce substance C and substance D, all in aqueous solution. So the equilibrium constant for this reaction is the product of the concentrations of the products raised to their coefficient exponents divided by the concentration of the reactants raised to their coefficient exponents. And if you think about what K represents, K is the ratio between the products and reactants at equilibrium. So when this reaction reaches equilibrium, this ratio will equal the equilibrium constant at a given temperature. If the numerator is greater than the denominator, then that means you have more products present than reactants. And so if you have more products present than reactants, that means that your reaction is product favored. And if the numerator is greater than the denominator, then the K value is going to be greater than 1. Now, typically, we talk about much greater than 1 to talk about whether a reaction is product favored or reactant favored. If K is much greater than 1, then we know that we're going to have many more products than we have reactants. So this reaction will be product favored. If the denominator is greater than the numerator, the denominator is your reactants. And so if the denominator is greater than the numerator, that means you have more reactants than you have products. And so the reaction is going to be reactant favored. So what is this going to look like for K? Well, if K is much less than 1, because if the denominator is greater than the numerator, then K will be less than 1. If K is much less than 1, then this is a reactant favored reaction. And we know that the reaction is not going to make as many products as it makes reactants. If K is much, much, much greater than 1, so if we have a very large K value, then that means that in essence, this reaction goes to completion. In other words, all of your reactants become products in that particular reaction. And if K is much, much less than 1, so if you have a very, very, very small K value, then the reaction does not occur. Or in essence, the reaction does not occur. So that's the essence of this particular topic. There's not a whole lot to it, but understanding what K values mean, what the magnitude of K value mean, gives you an idea about what the reaction is doing at equilibrium. I hope this was helpful, and if you have any questions, of course, please let me know. Good luck.